Look at another question here. At the top, we have 2 times 3 to the power x minus 1 plus 3 to the power x plus 1 in the numerator. In the denominator, we have 4 times 9 to the power x underneath a square root. Okay, so in the top, we have two terms because terms are separated by a plus and a minus sign. So this is one term, and that's a second term. So we split the bases at the top. 2 times 3 to the power x. 3 to the power x can be split to 3 to the power x times 3 to the power negative 1. Plus split 3 to the power x plus 1, 3 to the power x times 3 to the power 1. That's like the reverse of law number 1, splitting the base 3. Then 4 times. This is 3 to the power 2x with the square root. Okay, then let's move. Then we take out the common factor at the top. It's 3 to the power x. Left on the left with 2 times 3 to the power negative 1. On the right, we are left with 3 to the power 1 over 4 times. Now 3 to the power 2x, the square root of that, guys, 3 to the power 2x is actually the same thing as 3 to the power 2x, the whole thing to the power half. If we remove the square root, then it's raised to the power half. Or we could say 3 to the power 2x divided by 2. Hopefully that makes sense, guys. Either way, either notation is correct. What does that lead me? It leads me to the answer 3 to the power x, because 2 times a half gives me 1. The coefficient will be 1x. Or 2 divided by 2, that will also lead me to 3 to the power x. Hopefully you guys understand why then I'm going to write the answer 3 to the power x. Alright, because that's how the square root, when applied to the exponent, it basically is us dividing that to the power 2x by 2. Or it's like saying 2x times a half when we remove the square root. Hopefully that's clear for all of us. Now that we have arrived here, we can now cancel 3 to the power x and 3 to the power x. Why? Because we can cancel, because at the top, we now have 3 to the power x times this whole thing over 4 times 3 to the power x. Here we couldn't just go ahead and cancel 3 to the power x, okay, with the denominator. We couldn't do that because we cannot cancel across an addition sign. But whenever we now have established one term at the top, cancellation can freely then happen. We are then left with 2 times 3 to the power negative 1 over 3 to the power negative 1 is 1 over 3 plus 3 over 4. Okay, it would be 4 times 1, but you know 4 times 1 is equal to 4. So 2 times 1 over 3, applying BODMAS, is 2 over 3 plus 3 over 4. Then obviously we take care of the addition of the fraction. Obviously that addition of the fraction, we know we find the LCD, which is 3. So we times by 1, times by 1, times by 3, times by 3. Then we get 2 plus 9 over 3, which is actually 11 over 3. That 11 over 3 is divided by 4, which is actually 11 over 3 divided by 4 over 1, which is 11 over 3 times 1 over 4. Remember, when we change divide, change it to multiply the second fraction, it inverts. The numerator becomes the denominator becomes the numerator. Remember, this is 11 over 3. This line stands for divided by 4. Hence, we say 11 over 3 divided by 4. But 4 can be written as 4 over 1. Change the divide to multiply. When the multiplication sign gets introduced instead of the division sign, the fraction, that's the second fraction, will get inverted. Okay. Then final answer, 11 times 1 is 11, and 3 times 1, 3 times 4 is 12. That is how we simplify this exponential expression.